Hello, this is Prashant sir recording live for Vidyanti.com. This is last minute one shot revision for probability in under 1 hour. Hopefully this lecture will be useful. So let's begin. In this lecture we are going to do probability basic concepts and then we will be solving some examples. So the first thing we are going to see in this lecture is concept of sample space. Probability is the ratio of favorable thing upon how many overall ways that things can happen. So a set of all possibilities will be sample space. We are going to see the sample space for three things. One is coin, and we can have one coin or we can have two coins. If there is one coin, then there are only two possibilities, heads or tails. And if there are two coins, there will be four possibilities, head head, tail tail, head tail or tail head. So I have written here H stands for head, tail stands for T stands for tail, and you can have all four possibilities. If there are three coins or the same coin tossed three times, then there will be 8 possibilities. And we can write down these possibilities. In general, n coins will be 2 raised to n possibilities. In case of a die has 6 sides because a cube has 6 faces. So you can have any combination of integer starting from 1 all the way till 6. So you have 6 combinations, 1, 2, 3, 4, 5, 6 appearing as a score when you roll a single die. If you have two dice, then it will be 6 times 6, that will be 36 possible combinations. If you have card, we are going to see that in one question afterwards, all possible terminology in terms of as far as cards are concerned, but for the time being remember that there are 52 cards divided into 4 suits. Each suit has 13 cards. Now as I mentioned, probability is ratio, and that is like what you are looking for, favorable, that will be in the numerator, and the sample space will be in the denominator. Overall number of ways that thing can happen. So it's a ratio of favorable upon total, and that will be denoted by probability of event A. Probability of any event lies between 0 and 1, extreme values included, and that ratio cannot be less than 0, hence probability cannot be negative. At the same time, probability cannot be greater than 1. The extreme case is only 1. This is when you are expressing that in terms of a ratio. Occasionally, probability is expressed in terms of percentage, and the percentage wise it will be between 0% and 100%. Probability of A bar will be probability of that event not happening, so that will be 1 minus probability of event happening, because happening and not happening collectively it's 1 or 100%. So if you happen to know the probability of happening, then probability of not happening will be simply 1 minus that ratio. We can express that in terms of Venn diagram. The sample space, the overall possibility, is expressed in terms of a rectangle, so that is 1 or 100%. Now the circle represents the favorable thing, whatever we are looking for. So the circle is probability of happening, and anything which is outside the circle but still within the rectangle, that will be not happening. So collectively everything will be added 1. Having said that, let's go to the first problem, 14.1.1. Let's see some MCQs. Probability of an event E and probability of the event not E or E bar, collectively we know that it will be expressed just like what I have mentioned. That will be collectively everything, that will be 100% or simply 1. So the answer for this one is 1, but if you want to express that in terms of percentage, that will be 100%. Second question, probability of event that cannot happen. Well, we know that probability of an event is between 0 and 1. So on one side of the spectrum we have 0 probability, that is referred as impossible event, and on the other side of the spectrum we have 1 event, that will be sure shot event or certain event. Tomorrow the sun will rise towards the east, that will be a certain event. And let's say in the middle of desert, tomorrow it will be raining, that kind of impossible event or very rare event, so that will be towards 0 side. Probability of event that is certain to happen, we just covered that, is called 1, that's the sure event. The sum of probabilities of an elementary events of experiment. Now here, let's say, let's take the example of Vidyanti. We have students from 8th grade, 9th grade and 10th grade, and collectively that's all what we do. We don't teach beyond 10th grade for the time being, we don't teach beyond 8th grade. Now, these individual probabilities can be unequal. We have less number of 8th grade students, slightly more number of 9th grade students, but majority of our students are from 10th grade. So if you consider everything that encompasses, covers everything, all area from the rectangle, and that will be 1. So sum of all possibility of the elementary events is just 1 or 100%, simply because it covers everything in that rectangle. So if you take a random person, a random student from our institute, he will be either 8th grade, 9th grade or 10th grade, but if you add all probabilities, that will be simply 1. The probability of event greater than or equal to, well, it will be always greater than or equal to 0, but at the same time less than or equal to 1. Let's go to the next question. Which of the following cannot be? Let me repeat, it cannot be. So what's the possible values which are illogical, absurd, or cannot happen? 2 by 3. Well, probability of any event is between 0 and 1, extreme values included. 2 by 3 is between 0 and 1, so that's quite possible. Negative 1/5, that's impossible because probability cannot be negative, it cannot exceed 1 and it cannot go beyond 0. So this seems illogical. The next option is C, 15%. Now, even though it is greater than 1, remember here it is a percent. So, percent wise, it will be between 0% and 100%. So, that is still possible. And 0.7, that is also possible. So, illogical, absurd thing here is negative 1.5, that will be option B. The probability of E is 0.05. What is the probability of not E? We know that happening and not happening collectively is 1. So, if happening is 0.05, not happening will be simply 1 minus 0.5, 0.05, that will be outside the circle but still within the rectangle. So that will be 1 minus 0.005, 1 minus 0.05, that will be 0.95. Let's go to the next question. A bag contains lemon flavored candies only. Malini takes out one candy without looking at what is the probability that she takes out orange flavor candy and lemon flavor candy. Now, the given information is there is no such thing called orange flavor candy. All the candy which is in the bag right now are lemon flavor candy. So, if you are looking for something which is not there, that's impossible event. Malini, whatever she does or however whatever number of quantity she takes out from the bag, this is sure that the candy will be lemon flavored only because simply the bag has lemon flavor candy. So orange flavor candy is an impossible event, so that will be 0, and lemon flavor candy will be sure event because everything is there lemon flavored only. So that will be a certain event, so that will be 1. If you want, this can be 0% and 100%. Let's go to the next question. It is given that a group of 3 students, the probability of 2 students not having the same birthday is 0.992. So either 2 students will have same birthday or 2 students will have different birthday. There is only these 2 possibilities are there. So same birthday, if it is not having same birthday, is 0.992. So same birthday will be 1 minus, because collectively it will be 100% or 1. So if outside is 0.992, inside will be 1 minus 0.992. That will be 0.008, and that will be your answer. Let's go to the next question. So the final answer is 0.008, or if you want that percentage, multiply that by 100, that will be 0.8%. Let's go to the next question. A bag contains 3 red balls and 5 black balls. Okay. So altogether we have 8 balls. A ball is drawn at random from the bag. What is the probability? The ball drawn is red and not red. Now here altogether the sample space is 8 balls because we have altogether 3 plus 5 balls, which is 8. And out of that 3 are red. So probability of red, remember the fundamental formula is a ratio. Probability of red will be favorable upon total. Here favorable is a red thing, that's 3, and total is like 8. So probability of drawing a red ball will be favorable 3 divided by total 8. So the answer will be 3 divided by 8. Now probability of drawing not red, well, not red are 5, altogether it's 8, so it will be 5 upon 8. That's one way of doing it. Or you can use the concept of happening and not happening. Here not happening, which is not red, that is 1 minus red. So and red we have already calculated, so 1 minus 3 by 8. After cross multiplication and having common denominator, you still get an answer equal to 5 by 8. So whichever way you prefer, conceptually it will be having 5 by 8 as the correct answer. So the first question is answered as 3 by 8 and not red is 5 by 8. Let's go to the next question. A box contains 5 red marbles, 8 white marbles and 4 green marbles. A marble is taken out of the box at random, and what is the probability that marble taken out as red, white, not green? So again, probability concepts are not very difficult. You have to understand what they are asking, and it's just a matter of like plugging in the values in the ratio. If you happen to know the correct terminology, if you happen to know the correct sample space, it's just a matter of plugging in the values and simplifying the fraction at the most. Conceptually, they can ask you multiple choice questions or they can ask you simple questions like this one. So let's begin. A box contains 5 red marbles, 8 white marbles and 4 green marbles. Altogether we have 5 plus 8 plus 4, that comes out to be 5 plus 8 is 13 and plus 4 is 17. So altogether we have 17 marbles. So there are 17 possible ways we can draw a single marble out of it. So the sample space is 17, the denominator will be 17 and the numerator will keep on changing depending upon which question you are solving. So let's go to the first sub question, red. Now out of 17, 5 are red, so altogether favorable upon total, here favorable is 5 and total is 17. So probability of red is 5 over 17. Probability of white, second sub question, will be again favorable upon total. Now here favorable is white, that's 8 and total is 17. So it will be 8 over 17. As far as third question is concerned, not green. Now not green is what is the meaning of not green here? Not green means anything other than green. So that includes red marbles and that includes white marble too. So that means not green is 5 plus 8, 13 divided by 17. That's one way of looking at it. Or not green, this is one way. Second option is calculate the green, which is 4 upon 17, and not green is 1 minus green, so that's 1 minus 4 by 17, that will come out to be 13 by 17. Either way the answer should come out to the same. So you can actually physically count what is not green divided by sample space, which is 13 by 17. That's one way of doing it. Or the second option is not green. First, even though not green is asked, first calculate green, which is 4 by 13, and not green is 1 minus green, so that's 1 minus 4 upon 13. That's also come out to be 13 upon 17. So either way the answer is going to be the same. So these are your 3 answers for the 3 sub questions. Let's go to the next question. A piggy bank contains 100 50 paisa coins, 50 1 rupee coin, and 20 2 rupee coin, and 10 5 rupees coin. It is equally like that one of the coins will fall out. So there is no preference. Now some of you will say that, oh, the 50 paisa coin will be smaller, 10 rupee coin will be bigger, 5 rupee coin will be bigger. So there is a less chance. Technically, all those sarcastic and pessimistic people are technically correct. But just to eliminate the confusion, it has been clearly mentioned in the question that all those things are equally likely. So there is no preference size wise or any other weight wise or the shape wise. All are circular anyway. So everything is equally likely to fall down from the piggy bank. So if one coin falls out, what will be the chance or probability that it will be a 50 paisa coin? Well, altogether, how many coins we have? We have 100 50 paisa coin, 50 1 rupee coin, 20 2 rupee coins, and 10 5 rupees. So altogether we have 100 plus 50 plus 20 plus 10, that will be 180 coins. So this will be your sample space. This will go in the denominator forever. Now, if you are talking about 50 paisa coin, our favorable thing is 50 paisa coin. How many 50 paisa coins will be there? There are 100. So altogether numerator will be 100, because remember it is favorable upon total 100 coins divided by 180 coins. So that will be, on simplification, it will give you 5 upon 9, because we are cancelling 20, a factor of 20 from both numerator and denominator. Will not be a 5 rupee coin. Now you have two options. One, physically count those coins which do not qualify to be 5 rupees coin. So that will be anything and everything other than 5 rupees coin. So except these last 10 coins, everything qualifies to be not 5 rupee coin. So that will be 170. So it will be 170 divided by 180. On simplification, it will be 17 by 18. Another option is not 5 rupee coin. So first calculate 5 rupee coin, that will be 10 upon 180, and then simply do 1 minus uh, 5 rupee coin. So not 5 rupees, 1 minus 5 rupees. So that will be 1 minus 10 upon 180. So that will be 1 minus 1 upon 18. So that will also come out to be 17 upon 18. So this is your final answer. Let's go to the next question. Gopi buys a fish from the shop. The shopkeeper takes out one fish, and the tank contains 5 male fish and 8 female fish. What is the probability that Gopi gets a male fish? Altogether, there are 5 plus 8, which is 13 fish, and Gopi is looking for the probability of male fish, and there are 5 male fish. Remember, the probability is favorable upon total. So if he is looking for male fish, so it will be male 5 divided by total 13. So it will come out to be 5 upon 13. And that will be your final answer. So you have recognized that, you have realized that probability questions are not difficult, and most likely they can be asked for MCQ, which is 1 mark, fill in the blanks, which is 1 mark, or they can be asked conceptual questions as 2 marks. But nothing drastically difficult. All you have to do is like understand, interpret the question correctly, and if you know what they're asking, then it's just a matter of substitution. Let's go to the next question. A game of chance consists of spinning of an arrow, and that arrow can give you anything between 1 and 8. So let's see the diagram. They have given the figure. The diagram has like a spinning an arrow on the wheel, and there are 8 possibilities. So here everything is 8. So there are 8 possibilities. That's your sample space. So set of all possibilities 1, 2, 3, 4, 5, 6, 7, 8. So it will permanently go in the denominator. You will be dividing by 8, and whatever you are looking for. Now what you are looking for? 8. So out of 8, you have only one chance of getting the physical number, the actual number 8, and you will get 1 divided by 8, because out of 8 possibilities, there is only one possibility which is your favorable, and that's like 8. Second question, odd number. Now, how many odd numbers are there? Odd numbers are those which are not divisible by 2. So that will be 1, 3, 5, 7. You have to stop at 7, because after 9 there is nothing. So altogether we have 4 odd numbers, 1, 3, 5, 7 out of 8. So 4 divided by 8, which is upon simplification, you get half. Generally, if you have equal distribution of odd and even numbers, you get half and half, 50-50%, because both occur quite with the same frequency. So unless you have specifically one odd number extra or one even number extra or some missing number, generally these kind of questions you will get 1/2 or 50% of that as an answer. Number greater than 2, not equal to 2, not less than 2. So 1 is disqualified, 2 is also disqualified because they are strictly saying that greater than 2. How many numbers are there greater than 2? 3, 4, 5, 6, 7, 8. There are altogether 6 numbers which are greater than 2. Out of 8 possibilities, 6 are favorable. So that will be probability of greater than 2 will be 6, which is favorable, divided by 8, which is total. So 3 upon 4. Fourth, a number less than 9. Well, everything is less than 9, so that sounds weird, but occasionally you can be asked these kind of questions. Now remember, weird questions will get like extreme answers. Here, a number less than 1, well, everything is less than 1, so everything is your favorable. Out of 8 possibilities, everything qualifies for favorable. So 8 out of 8 are your favorable. So that would be 8 divided by 8 or 1. So whatever you do, however you spin that with full force, upside down, you are like kind of dizzy. Still, whatever you do, whatever is the arrow pointing, that is sure shot to be less than 9 because everything is less than 9. So your probability is going to be 1, and this is an example of sure or certain event. Let's go to the next question. 14, a die is thrown once. Find the probability of getting a prime number. Now, as far as a die is concerned, it's a cube. It has 6 sides, so it will give you 6 possible numbers. 1, 2, 3, 4, 5, 6. So your sample space will be 6 possibilities. So 6 will be permanently going into the denominator because that's the sample space. Everything that can happen. Set of all possibilities. Now we are looking for specifically prime number. Now what is the prime number? Here there can be confusion. 1 is neither prime nor composite. Prime number actually starts from 2 onwards. A prime number is defined that number which has only 2 factors, 1 and that number itself. So you have, what are the possible prime numbers? 2 is a prime number, 3 is a prime number, 4 is not because it is divisible by 2, 6 is also not a prime number. So out of these 6 possibilities, 3 are favorable because these are the 3 prime numbers. As long as you understand the meaning of prime numbers, as long as you understand a die has 6 possibilities altogether, so it's just a matter of picking up prime numbers from the set of all possible all possibilities, which is sample space. So there are 3 things out of 6. So that will be 3 out of 6, which is 1 by 2, and that will be your answer of getting prime number probability. Second case will be a number lying between 2 and 6. Between 2 and 6. So that means 2 is disqualified, 6 is disqualified. So you can have 3, yes, 4, yes, 5, yes. So again, there are 3 possibilities out of 6 possibilities. So that would be 3 out of 6. Again, we will have 1 by 2 as your answer. So probability of odd number, that will be your last question. Odd number is you have 1, 3 and 5. 1, 3 and 5, there are 3 possibilities. Again, out of 6 possibilities, 3 are favorable. So your answer is going to be 3 by 6. So that will be 1 by 2. Let's go to the next question. One card is drawn, and this we are going to see in detail because we are going to revise some terminology about cards. One card is drawn from a well shuffled deck of 52 cards. Well shuffled means mixed properly. You might have seen that when you play cards, to make sure that everybody gets a fair chance and nobody is like getting something hands from the previous time. So they shuffle the cards. In casino, you have proper machines, but if you are playing at ordinary level, by hand, we actually well shuffle, properly mix those cards. That is the meaning of well shuffle. A deck means complete pack of 52 cards. So let us see the terminology because here they're talking about red card, blue card, black card, spade, club, face card, number card. So I'm going to just quickly revise the terminology. A card can be of two color, red color or black color. Red color is divided into two suits and black color is divided into suits, two suits. Red card can be heart or red card can be diamond, and black card can be club, and it can be spade. So uh, let's see their symbols. That will help you understand, because you might be knowing these things in your local language but not in English. Those who are studying, who are speaking, their mother tongue is different than English, they might be playing cards not knowing the proper terminology. So let's take a small moment and then we go through this terminology really quick. The first card, the topmost value card, is 1, which is ace. And then you have number cards all the way going till 10. So you have ace of heart, ace of diamond, ace of club, ace of spade. Then you have 2 of heart, 2 of diamond, 2 of club, and 2 of spade. And so on. This goes up to 10. Up to 10, you have number displayed on the card. After 10, so these are called number cards simply because they are recognized by the number value. And ace is like the strongest, 2 is actually the least, 3 is a little bit stronger, 4 is even stronger, and so on. And after number cards, you have 3 face cards, because they are jack or joker, queen, king. These are called face cards simply because the face of joker, king, and queen are imprinted on that particular face. And now we have, that means we have 13 hearts, uh, 10, 10 number hearts and 3 face hearts. Similarly, you can have 13 diamonds, 13 club, and 13 spade. So altogether 13 times 4 is 52. That's the total number of cards you are going to have. Now, having this into your mind, let's go through these conditions one by one. A king of red color. Well, you are looking, altogether there are 15 cards, 52 cards. So the total number of possibilities or sample space here is 52. That will go permanently in the denominator. Now numerator will change depending upon what you are looking for. Depending upon every sub question, numerator will be different. Denominator will be always 52 as long as you are drawing single card. So a king of red color. How many kings are there of red color? So I'm going to show that with like animated rectangle. So you have 2 red kings. Remember, even though there are 4 kings, only 2 of them are red. So that will be king of heart and king of diamond. So out of 52, you are having only 2 possibilities which are favorable. So that will be 2 upon 52, which is on simplification, it will become 1 over 26. Second question will be a face card. Now, face card, there are plenty of face cards. In fact, there are 12 face cards, 3 from each suit, and there are 4 such suits. So I have shown them again animated rectangle. Altogether, there are 12 face cards out of 52 possible cards. So that will be 12 upon 52. Now note that since we have 4 suits, most of the times 4 will be the common factor, and that you can eliminate from numerator as well as a denominator. And that will be 3 upon 30. Let's go to the next question. A red face card. A red face card, that will be, again I have shown here with animated rectangle, there will be 6 uh, face card which belong to the red color, and that will be 6 upon 52. Note that in most of the times, as long as you are drawing one card, the numerator is changing, but denominator is always 52. And upon simplification, it will be 3 upon 26. The next question, jack of hearts. Well, there is only one jack of heart out of 52. So that will be 1 over 52. A spade. Well, there are 13 spades altogether. 10 face and 10 number and 3 face. So 13 out of 52, upon simplification, it will become 1 over 4. Last question is the queen of diamonds. There is only one queen of diamond. That will be what I have shown here. So it's 1 over 52. So again, if you know the basic terminology and if you know that there are 52 cards, it's just a matter of finding out how many things qualify for the given condition. Those will be your favorable things, and they will go in the numerator. So there is no need to worry. In fact, I believe out of all chapters, probability is the simplest chapter. And if you have grip on this basic terminology, And if you know the basic formula, which is favorable upon total, you know that probability cannot exceed 1, it cannot go into negative. So as long as you know these basic things, that is fine. Let's go to the next question. 5 cards, 10, Jack, Queen, King, and Ace of diamonds are well shuffled with their face downwards. So there are only 5 cards. Now we are not talking about all 52 cards. There are only 5 cards, and those 5 cards only are under consideration. So forget about what we have done for the complete deck, which is 52 cards. Now we are talking about only 5 cards. Here the sample space is very narrow, very limited, very shallow. So that is only 5. So this 5 will be set of all possibilities that will go permanently in the denominator. What is the probability the card is a queen? Well, there are, how many queens are there in this one? There are only 1 queen out of 5 cards, so that will be 1 over 5. Second, uh, if the queen is drawn and put aside, so now the queen is taken out in the previous question and it is kept aside. This is important because if you keep it aside versus if you allow to mix it again, so that changes the value of probability. Here they have specifically mentioned that the queen is drawn and it is kept aside. So that means now instead of 5 cards, now we have only 4 cards because 1 card is totally out of our selection process. So after the queen is put aside, now the total number of cards will be only 4, and there are no queens remaining because the queen is specifically the card uh, which is which has been kept aside. So now we have only 4 cards, that too without any queen. So the second card will be ace. Well, there is still 1 ace remaining out of 4 cards, so that will be 1 over 4. And second, a queen. Well, there is absolute no queen remaining in the remaining 4 cards, so that will be 0 over 4. That will be simply 0. So your final answer will be 1/5 and then 1/4 and then 0. Let's go to the next question. 12 defective pens are accidentally mixed with 132 good ones. Now altogether there will be 12 which are bad, defective, and 132 good. So that will be altogether there will be 144 pens. So your sample space set of all possibilities, way of selecting everything is 144, that will go into the denominator. Now out of 144, 12 are bad and 132 are good. So determine the probability that the pen taken out is a good one. How many things are good? 132. How many things are total? 144. So favorable upon total, that will be good upon total, 132 upon 144. Now there is a common fact of 12. You can divide both things by 12, and that upon simplification and cancellation, you will get final answer as 11 by 12. Remember, this 11 by 12 is still less than 1, so this is still a good answer. You should have a habit of checking the answers whether they are still within 0 to 1 range or 0% to 100% range. If something is exceeding this range, that means your calculations are bad, and you should go back and recheck your calculations. Let's go to the next question. A lot of 20 bulbs and 4 contain 4 defective. So now we have 20 altogether. Now here you have to be very careful about wording. In the previous case, the good ones and bad ones were given separately and we mixed them together, found out the total. Here the number which is given for the bulbs, that includes good and bad, so we have to subtract. So occasionally if separate things are given, separate lots are given, we have to add the number to make a grand total. But here the grand total is already given, which is 20 bulbs, and out of that 4 are defective. So out of 20 we have 4 defective and 16 non-defective or good ones. One bulb is drawn, what is the probability that it is defective? So out of 20 bulbs, 4 are defective. So here n stands for number of defective. How many ways you can have favorable, which is number of defective ones. Remember, if you are finding the probability of defective one, then the favorable is defective. Don't think that favorable means good and non-favorable. Favorable means what we are looking for. If you are looking for a bad guy, if the cops are looking for a thief, then favorable is the thief, even though he is actually bad in real life. So favorable doesn't necessarily mean good. If you are hunting for bad thing, if you are hunting for bad guy, then the bad guy is the favorable one, because that's the specific thing which you are looking for. So what we are looking for, what we are searching for, what is given in the condition, that always goes in the numerator. That doesn't mean it's a good one or a bad one. That's the specific thing what we are looking for. So I don't say good upon all, I say favorable upon total. Favorable is the thing which you are specifically looking for. So number of defective is 4, number of total is 20, so it will be 4 by 20, and that will be your final answer. In the second case, suppose the bulb drawn is not defective and it is not replaced. Okay, so it is kept aside. Not replaced means kept aside. So now out of 20 total, one has been already removed. So now we have still 19 bulb. And since the first bulb is non-defective, so it was good one. So we still have 4 defective, and since the first one was good one, out of 16, now 1 is less. So we have the new situation is like this. One bulb is replaced, is not replaced. So that's why it is from 20 it became 19. And we know that the previously drawn bulb was non-defective. So the defective one are still 4, but the non-defective will be reducing by 1. So we have this new distribution as our new scenario. So now what is the probability that the bulb is non-defective? So we have still 15 non-defective bulbs in a lot of 19. So your answer is going to be 15 upon 19. So you have to be careful about two things. Number one, whether it is replaced or not replaced. If it is not replaced, then the total number goes down by 1. And if they have already given you what kind of bulb was drawn in the previous attempt, so subsequently, according to the information, you have to reduce either defective by 1 or non-defective by 1, depending upon the first drawn bulb was defective or non-defective. So that means your answer will be 15 upon 19, and that will be your final answer. Let's go to the next question. 14.1.18. A box contains 90 discs which are numbered from 1 to 90, and one disc is drawn at random from the box. When they say random, equally likely, so that means there is no bias. That means there is no specifically preferable something. Everything is equally likely. Everything is possible. Everybody has equal and unique chance of being drawn. Find the probability that it bears a 2-digit number. Now we have altogether 90 numbers, 1 to 90. So the sample space will be 90. So that will be the number which will go into the denominator. And in the numerator, first we are looking for a 2-digit number. So favorable thing will be a 2-digit number. Out of 90 numbers, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 are 1 digit. So the remaining 81, 90 minus 9 will be 2-digit number. So altogether we have 90 numbers. Out of that we have 81 numbers which qualify to be 2-digit. So favorable upon total, 81 divided by 90. Upon simplification you get 9 divided by 10. A perfect square number. Now how many squares are there? From the given lot, so from 1 to 90, you have 1, 4, 9, 16, 25, 36, 49, 64, and you have to stop at 81 because the next perfect square is 10 square, which is 100. That's not within 1 to 90, so that's not counted. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 numbers which are perfect square out of 90 possible numbers. So the probability of finding a perfect square will be favorable upon total. Favorable is 9, altogether it's 90. Upon simplification you get 1 over 10 or 10%. The third question, number divisible by 5. That will divisible 5 will be 5, 10, 15, 20. So you make a list of all such things which qualify, which are favorable. And there are 3, 3, 6, 7, 9, 10, 11, 12, 13, 14, 15. There are 18 such numbers out of 90. So the probability of getting a number which is divisible by 5, that will be favorable upon total. There are 18 such numbers which qualify the given criteria, that will be 18. And altogether we have 90 that will remain in the denominator. So your answer is 18 divided by 90. Upon simplification That will come out with 1 over 5, and that will be your final answer. Let's go to the next question. A child has a die. It has 6 faces. Now this is interesting. You will expect that A, B, C, D, E, F. No, but somehow that number A appears twice. So here everything is not equally likely. A has more chance compared to the other alphabets. So now the die is thrown once. What is the probability of getting A and D? There are 6 sides, so there are altogether 6 possibilities. Out of that, number of ways you can draw A is 2. So out of 6, there are 2 A's. So 2 divided by 6 will be your answer for the first one, probability of drawing A. That will be 1/3. And as far as the D is concerned, D is not special. D has only one chance out of 6. So the probability of D will be number of ways you can draw a D. N stands for number of ways you can draw D. Upon number of ways you can do this thing overall, total. So that will be 1 divided by 6. Let's go to the next question. Suppose you drop a die at random in rectangular region shown in 14.6. What is the probability that it will land inside the circle with a diameter of 1? So you have altogether a rectangle, and the dimensions are given as 3 by 2. So altogether it has an area of 6 meters square. Out of that, the area of the circle is, well, the diameter is given as 1. So you can get radius as half, or you can use pi d square by 4. So it is probability of dropping a die inside the circle. Well, it depends upon their relative areas. The favorable is circle, overall is a rectangle, the circle is completely embedded in the rectangle. So the probability will be area of the circle, that's my favorite area, and area of the rectangle, that's my overall area. So area of the circle is pi by 4, or pi r square. R here is a diameter by 2. So pi times half square, and overall area is 3 by 2. So on simplification, it will come out to be pi divided by 24. Since the value of pi is not given, you can keep the answer as pi divided by 24, and that's your final answer. So just remember that if you drop something, the probability of A is proportional to the area. Larger the area, larger the probability. Smaller the area, smaller the probability. So it's proportional to area. It depends upon area. A lot consists of, this is similar to the previous one, 144 ball pens, which are having 20 defective ones. And obviously, if somebody is buying the pen, he or she will not buy it if it's defective. Shopkeeper gives a pen at random. Well, out of 144, you have 20 defective, and the remaining 124 are good ones or non-defective. Well, probability of defective, probability of buying is probability of good, probability of not buying is probability bad. So probability of buying is good upon total, that will be 124 upon 144. You can simplify that further if you want. Probability of not buying is 1 minus buying, that's one way, or you can say probability of defective, which is defective upon total. Either way, the answer will come out to the same, 20 divided by 144. These are your final answers. 14.122, complete the following table. Now, okay, the question here is you are rolling a die, 6-sided die, twice, or you are rolling two dice one by altogether. Now, what is the probability? Now, if you have two dice rolled together simultaneously, or if you have one die rolled twice, then you have 6 times 6, 36 possibilities. You can have 1 in the first attempt, and you can have 1 again in the second attempt. You can have 1 first attempt, 2 in the second attempt, 1 3, 1 4, 1 5, 1 6. And then you can have 2 in the first attempt, then 1 in the second attempt, 2 2, 2 3, and so on. Then you can have 3 1, and so on, 4 1, so on, 5 1, and 6 1 series. So altogether, there are 36 possibilities, and all 36 possibilities I have mentioned here. So you count in 1 2 3 4 5 6 brackets, then 6 more brackets, 6 more brackets, 6 more brackets. Altogether, 6 times 6 will be 36 brackets, or 36 pairs or possibilities will be there. So uh, sum is defined as the total of what you get in the first attempt plus what you get in the second attempt. Now, sum 2 is possible only in this attempt, which is if you get 1 and 1. So that is like there is only 1 out of 36 possibilities. Now, 3, when will you get 3? You will get 2 1 or 1 2. So you have 2 such possibilities out of 36. When will you get 4? You get 3 1, 2 2, and 1 3. So altogether, you have 3 such possibilities. Note that there is some pattern, there is some design, and because of that, the probability is slightly increasing. This will go on, and this will become 4 by 36, then it will become 5 by 36, then it will become 6 by 36, and now you have to be careful. Then again, it depletes or decrements by 1. It will become 5 by 36, it will become 4 by 36, it will decrease 3 by 36, 2 by 36, and finally 12 is kind of rare. You have only 1 out of 36 possibilities, because in order to get a score of 12, you must throw 6 in the first attempt, you must score 6 in the second attempt. So that means there is only 1 chance out of 36 possibilities. So that's why getting a score of 12 is kind of rare, and getting a score of 2 is also rare. Getting a score of 6, 7, 8 is a relatively okay. So this is the table. A game consists of tossing a 1 rupee coin 3 times. Well, here the coin, which has 2 sides, heads and tails, is thrown 3 times. So it will become, you will have 2 raised to n, which is 2 raised to 3, which is 2 times 2 times 2. The 8 possibilities are there. Now, let's make a list of 8 such possibilities. And if you write them randomly, there is a chance that you will skip one, you will miss one. So I'm going to make some rule or some logic out of it. Well, all 3 can be heads, all 3 can be tails. So I cover at least 2 possibilities. Then I can get one tail. That's one tail can be in the last, one tail can be in the middle, one tail can be in the first. So if I get one tail, there are 3 such possibilities: last, middle, and first. Similarly, if I get one head, that can be last, middle, and first. So altogether 1, 3, 3, 1. So altogether I have 8 possibilities, and this is matching with this one. So now I have covered everything, because people normally they write randomly and then they get only 6 or 7 at the most, and then they scratch their head like which one I have missed. So logically, let's make a list. All 3 heads, one possibility. All 3 tails, that's also one possibility. And then one head, there are 3 possibilities: last, middle, first. And one head, that is also 3 possibilities: last, middle, first. So out of this, uh, Hanif wins if all tosses give the same result. So all tosses give same result. So Hanif wins if all 3 heads, which is like same result, and all 3 tails, again TTT, same result, HHH, same result. That's why Hanif wins. And in the middle 6 cases, Hanif loses. So calculate the probability that Hanif will lose. Hanif will lose in 6 cases out of 8 possible scenarios. So it is 6 divided by 8. Upon simplification, it will come out to be 3 divided by 4. That's 0.75, or 75% of the times Hanif will lose. The remaining 25% times he will lose. 2 out of 8 he is winning, 6 out of 8 he is losing. Let's go to the next question. A die is thrown twice. What is the probability that 5 will not come in either time? So again, you have this 36 possibilities. We want 5 will not come in either time. So we absolutely hate 5. So how many ways 5 will not come? So these are the ways where 5 is not there. These are the ways also 5 is not there. This is also the shaded area. So altogether 16 plus 4 plus 4 plus 1. So I believe it's 25 times. Out of 36 times, 5 will not come. And the second question is 5 will come up at least once. So 5 will come at least one, that is this one and this one. So altogether this is 6, and this is also 6, but that's not 12 because this 5 by 5 is already counted. So it is 6 plus 5. So altogether it is 11 by 36. Note that this 25 by 36 and 11 by 36 collectively add to 36 by 36. that's equal to 1. So happening and not happening collectively equal to 1. That is what we have seen at the beginning of the lecture. So that is still valid. Let's go to the next question. Which of the following arguments are correct? If two coins are tossed, there are three possible outcomes: two heads, two tails, one over each one. If there are two coins are tossed, then there are four possibilities. Two heads is 1 by 4, two tails is 1 out of 4, and one head, one tail is 2 out of 4. So these are not equally likely. Equally likely means the probability come out to be equal. So in that case, all three numbers, all three ratios, if they are equal, then we can say equal. Since these numbers are kind of messed up, so we cannot say these are actually not equally likely. So this statement is incorrect. If a die is thrown, there are two possible outcomes: odd number, even number. This is correct because odd numbers are 3 out of 6, and even numbers are also 3 out of 6. So the probability are here you can say that getting an odd number or even number are equally likely outcomes because their probability is same. So that's all for the probability. These are the basic questions. I am sure that they will ask something related to textbook, just change the scenario, change the numbers here and there, modify the situations. Nothing drastically will ask. This is the actual first lesson of probability. Probability is actually a big chapter. Eventually, you will learn that in grade 11 and 12, irrespective of whatever you go to science or commerce. You will still learn it as long as there is a mathematics. Since this was your first introduction to probability, the questions which you are seeing, they are kind of elementary or very basic level. Probability is actually much more complex and complicated than what you are seeing in grade 10 level. But that's good thing because they will not twist and turn it even further. And I believe whatever we have done from the standard textbook, similar to that, we will be asked question. If you think I have gone a little bit faster, all these questions are individually solved in as an individual separate video, and they are listed in the YouTube playlist, the same channel. This is our channel address. If you want, you can visit the website and get it from there. See the individual video if you are specifically looking for a particular question solution. And the um, second thing is you can alternatively go to our website, which is www.vidyanti.com. Uh, it has AI generated notes and all solutions from grade 8, 9, 10 for math, science, and social science. Please recommend that to your friends. And if you're happy, please like, comment, or subscribe, share with your friends. That's all for the time being. This is Professor Prashant More, recording for vidyanti.com. In case if you are interested, these are my credentials. But most importantly, we want to wish you all the best for your exams. And that's all for the time being. Thank you very much. Hopefully, we will see you for revision for next lectures. Thank you.